Awesome. Good morning, everyone. We'll go ahead and get started. So today I'm going to be speaking about MLOps in FinTech. Um, this is a bit of a maybe extension of our last one, which was just about MLOps more broadly. I thought it would be interesting to do one very specifically tied to FinTech. So the agenda today is we're going to define common use cases of machine learning in FinTech. We're going to break down unique MLOps concerns for fintechs, and then we'll walk through a case study of MLOps and how that will create value for a fintech. So part of why we're doing this series is just to kind of give a sense of what we see happening across MLOps over the last few years. In 2021, there was a huge explosion of MLOps. That sort of peaked in about 2022, I think, when there was just like 1,000 MLOps companies. Everyone was talking about MLOps. And to an extent, for where the industry was at, it was a little over we weren't there yet to justify that. In 2023, last year, there was a market shift back away from MLOps. But towards the end of that year, and then now very much so, I've seen things move into a much more stable state where we're seeing MLOps actually drive huge business outcomes for massive companies. On the other side, so MLOps is kind of on its way up. On the other side, in fintech, we've just continued to see nonstop growth. Some of these maybe sub-industries have shrunk, but in general, we're seeing huge growth still in fintech. So fintech remains one of a huge sector in startups. Beyond that, it is a sector that I believe uniquely benefits from machine learning. Almost every core function or every, let's call it secondary function of fintech is empowered by machine learning. They kind of typically falls, I would put them into like three categories. One is much more back office, risk management, fraud protection, etc., which I have here. For some cases, you might get trading and investment if you work in that sort of space. There's a lot of machine learning there, obviously. And then finally, customer experience and operational efficiency, where you can do things from personalization, customer service, even things just like computer vision on documents can really go a long way. So these are the core components or some of core use cases I see a lot around machine learning in fintech. And one thing that's interesting here to me is that most of these things are deeply tied to ROI. They're almost all tied to revenue in some way, like fraud detection, risk management, customer success, personalization. A lot of these things, trading and investment, a lot of these things are deeply tied to revenue for the companies, which means that they can invest a lot of resources into machine learning, and doing so would actually benefit the business as a whole. MLOps is stabilizing. It's much more so in this year than we've seen in the past. Best practices are forming. It's starting to become much more clear what good MLOps looks like, where I don't think we could have said that 2 or 3 years ago. And finally, and most importantly, in my opinion, ROI now matters. You need to justify why you're investing however much resources into MLOps. And like I said, in fintech, there's a unique situation where doing risk management, fraud prevention, trading and investment, customer experience, operational efficiency better is directly tied to a business's ROI. So if you were to do machine learning better in a fintech, the company as a whole would be better. This is not true for all use cases. This isn't true for every stage of company or every scale of company. But for almost every fintech with reasonable scale, we start to see machine learning become a core function of the organization. If we can operationalize machine learning better in fintech, we'd be able to drive more impactful business outcomes. And I think that starts to get into how we even think about and measure MLOps. So if machine learning teams aren't driving real metrics, like real outcomes that the business cares about, MLOps doesn't matter because it's almost like you're doing nothing faster, right? It's not if the machine learning you're doing isn't actually driving business outcome, then who cares about how fast and operationally efficient you are in doing that? But in situations like we see in most fintechs where machine learning directly drives real outcomes for the business, but MLOps becomes a huge focus because you can directly make those outcomes better. You can make machine learning, you can iterate faster on machine learning. You can make sure that your models, which typically are going to be much more core, they can't go down, are more resilient, are better. And all that comes together to make the organization better as a whole. So in a sense, you need to be able to draw a line from MLOps to business metrics to justify MLOps investment. If you can't see that, or if that's unclear, then MLOps doesn't really matter. If it is clear, then it becomes much more obvious how much to invest in MLOps. MLOps in itself, I've been saying it, but the definition I would give is it's a set of tools and practices to automate and streamline the ML model lifecycle from ideation to production. So going back here, if we have machine learning teams that drive real metrics, so we have models that are actually driving metrics that matter to the company, but having a set of tools and practices to automate and streamline the creation of those models and the iteration and the evolution of those models directly drives business impact. I'm going to break down like the different types of impact and the different ways to think about MLOps because there's a lot of things that come together. One piece which I like to start with because it's almost like the bottom of the pyramid is what I would call I kind of take this from DevOps. In DevOps, there's this idea of DORA metrics, which are deployment frequency, lead time from change, time to restore, and change failure rate. Those things kind of tied to throughput, velocity, and risk. So one piece of MLOps is just the ability to deploy models and feature pipelines quickly, efficiently, and be able to handle failures, which surely will happen. Both like the how do we fix failures and also the do we catch failures before they make it to production. So this is one aspect of MLOps, which is more looking at it from the DevOps view. The second aspect of MLOps that I like is the product delivery view, or more the team view, let's say. This is the ability for a data science team or an ML engineering team to be able to work quickly. So the three components, the axes of an ML team working well, are velocity, throughput, and risk management. Velocity is the ability for each ML engineer to move quickly. Throughput is their ability to collaborate well. And risk management is their ability to do all that without accidentally triggering any sort of compliance risk that you would expect to see in a fintech. Like if you're working with financial data, there's a lot of regulatory risk involved, and you want to make sure that there are guardrails to make sure it doesn't happen. The final piece, and the way I like to think about MLOps, is treating our MLOps platform like a product. So using product metrics. When you think about MLOps from the perspective of like my MLOps platform as a product, well, like any product manager, you start by asking who's our user. And if you have a software background like I do, you'll see that a data scientist and an ML engineer to a lesser extent, they come from very different technical backgrounds, which typically will mean that the way they think and process problems will be very different from how we do in software engineering. Our goal is to solve cognitive overload, with MLOps. Make it very easy for someone to just be able to kind of achieve flow while iterating on their models. So we have to start by understanding, one, who the user is. And once we do that, we can kind of begin to understand how they think to eventually solve the problem of making their lives easier. And those kind of drive platform metrics like number of users and how often they're using it. If you build an MLOps platform and no one's using it, it doesn't really matter, right? Um, Below that, you need to make sure that as they're using it, they are driving. Well, I guess I'll start from the bottom up. From the bottom, you need to have an MLOps platform which is just generally solves your requirements. This can mean it can serve features or serve predictions under a certain amount of latency. It can handle a certain amount of load. It has a certain amount of uptime. If you don't have those concerns checked off, then the rest of it doesn't matter. It needs to solve the core problem of operationalizing a machine learning model. Once you have that, then you start thinking about iteration. You start thinking about, hey, how fast can we update models? How easily can an individual data scientist or ML engineer iterate on the model? How likely or how safe are our iterations? Do we typically see degradation in production? Do we see models failing? Do we end up with any regulatory problems? And then finally, once you solve those two things, you need to make sure that the product is nice to use. If you technically solve the bottom two, but no one likes using your framework or platform, then again, you haven't really solved the real problem. So breaking it down a bit, these are kind of the three the hierarchy of needs from the bottom up. These are things that you could measure to kind of really see these things. So the bottom would be like SLAs, latency, number of incidents, user satisfaction, NPS on the other side, and then finally weekly active users, engagement, and adoption. These things will change based on your industry and based on your size of company. So I'm again keeping this very tied to fintech. So I'll kind of continue to come back to fintech for this talk. But I will kind of abstract away the size of the company. However, if you're a single data scientist, your needs are going to be quite different from if you're a giant organization. For a single data scientist, it's typically much more about tracking. It's keeping track of what you're doing automatically and being able to really easily train and deploy models. It's much more focused on ease of use and automatic documentation than it is on anything else. As teams grow, then you start to hit the pain points of collaboration, documentation, reuse and resource sharing, monitoring, evaluation. You essentially go from being a single person to a team. And so everything that comes, all the pain points that come with kind of evolving into a team start to come into play. And the MLOps platform needs to solve those things. Finally, there's the organizational view. In the organizational view, these are going to be much larger companies. You start to worry about heterogeneous infrastructure. You might have Snowflake and Spark, or you have different data platforms in different places. You have governance, access control, audit log problems. So you are typically larger, which means that you have more of a microscope on you with regards to your practices and regulation. And then finally, at that scale, it becomes much more common to interact with other non-engineering teams like legal and marketing, as well as other engineering teams. There's other platform teams that you will interact with. So having cross-functional workflows be built into the platform become core. Okay, so that was a lot of information. I went through it pretty fast. I want to spend the rest of this time getting a bit more technical. Everything I've talked about so far has been how to think about MLOps in a fintech. So a little less technical, much more focused on how a maybe non-MLOps executive will think about MLOps. And I think it's really important if you are a practitioner or maybe you run an MLOps team to see how and think from the perspective of one higher up, one abstraction up, because in the end, that's what's going to allow you to be able to really drive value where it makes sense to drive value. I should also mention that at any point in time, for people listening, if you're on LinkedIn or Twitter, or if you're on the Zoom webinar, you can always throw in your questions, and I'll make sure to answer them. If you have any so far, feel free to throw them down. As I go through this next stage, which will be slightly more technical, also feel free to throw them down. So let's begin breaking down the MLOps platform, and we'll keep a FinTech perspective to this. We'll start by breaking down the model lifecycle. The model lifecycle is in 4 parts. There's the data piece, data set engineering, data analysis, feature engineering, model experimentation and training, which is kind of once you have data, you can start experimenting on model, hyperparameter tuning. Once you have models that are ready to put in production, you need the ability to deploy and serve those models. And then finally, once your models are in production, you need to start worrying about monitoring and evaluation. So these are the different parts, stages of the ML lifecycle. Now, I draw as a line as if you're going from left to right. In practice, you'll be jumping around between all these things. But each of these different parts of the lifecycle, they have different rules. Like the way you do model deployment and the way you do data analysis they just look so different. The type of tooling you'd want to use is going to be completely different. So thinking about the lifecycle in this way helps us pick the right tools to solve the job to be done. On the other side, this is something that kind of we came up with at Feature Form, is the different levels of abstraction from layer 0, which we call the hardware level, up to level 4, which we call the platform level. So if you were to combine or the stage of ML lifecycle and the level of abstraction dimension, you'd end up with some grid that looks like this, where the bottom is just the different parts of the lifecycle, and the top are the levels of abstraction that you layer on. And we can fill those in. And I'm going to go through this and break this down, and I'll break it down from a FinTech perspective as well. So first, let's start at the very bottom. We have layer 0 and layer 1. Now, notice that these are agnostic typically to the ML lifecycle underneath it. So we don't really care if you're in the data stage or the experimentation stage or the deployment stage. A layer 0, it's a hardware. It could be like EC2. Layer 1's compute frameworks. It could be something like Kubernetes. It could be Array. It could be you're using maybe like Databricks' compute platform. These are typically a little more agnostic to ML or a little lower level, but you need to build on top of these. And your layers above it need to play nice with the layers below it. For example, if you have stuff if you're on-prem, that might limit the types of things you're allowed to use above these 2 layers. Now we'll get to the MLOps layers, the kind of layer 2 and 3. The reason why I break MLOps down into 2 layers is I view it as there's 2 distinct problems to be solved. There's the engine problem, which is the ability to serve data or serve predictions. They're compute problems. Like, how do we scale our compute? How do we get the levels of performance we need and the level of uptime we need? That's a lower layer than the workflow layer. The workflow layer is much more about people, organizational problems. These are things like versioning, documentation, reuse, collaboration. Those would fall in my world in the workflow problems. So there's engine problems and workflow problems. And in this breakdown we put layer 2 services as the engine problem and layer 3 as the workflow problem. And we have different tools for data, experimentation, deployment, and monitoring for these 4. Let's start with data. So on the data side, We have data set engineering, data analysis, feature engineering, and feature serving. So the engine problem, the services layer, we need something like Spark or Redis or something else that allows us to compute the data sets, do our data analysis, do our feature engineering, run those pipelines, and then to serve them as well. Now, in practice, what you'll find is that you'll end up with all of these different feature pipelines. They'll be all over. They will be undocumented. We'll have different forms of scheduling. You won't be able to look at the training set and get its lineage, understand where it came from. And that's why you need something above it to do orchestration and management of those feature pipelines. And that's actually why we built FeatureForm. So FeatureForm sits above your data infrastructure. That could be Spark, it could be Redis, it could be Snowflake, it could be all of them. And it allows them to work together coherently to allow you to quickly iterate, deploy, manage, and serve your features. So breaking it down, there's the engine problem and the workflow problem. The engine problem is, how do I service data? How do I deal with streaming data? Let's think again from the FinTech perspective. We might be doing something like fraud detection. Well, fraud detection, we may want to work with streaming data. In transaction data, we might end up with tons of data. We might end up with petabytes of data. So we need an engine which solves those problems. On the layer above, if you're a FinTech with a dozen data scientists, you're going to hit problems with regards to versioning and analysis. And how do I get my feature pipelines into production out of a notebook? How do I do monitoring, lineage, share and reuse, governance? These are all the things that make ML teams go from being these ad hoc processes that we do on top of powerful data infrastructure to a coherent workflow. It's almost like DevOps in a way. Like, think of how things were done before DevOps. Like, everything was super ad hoc. We'd like copy binaries to servers and run them there. Like, that was considered commonplace. And it was painful. And so MLOps solves a lot of the same problems that DevOps did in a different kind of problem space. Cool. So that was the first layer. That was the data layer. Next, we'll go to the model experimentation training layer. Experimentation and training, we need the ability to literally train the model itself. So that if I give it a data set and a model, it will train quickly and maybe do things like hyperparameter optimization. But I also need to solve my workflow problems, which are experiment tracking, model artifact tracking, so like a model store, and the ability to compare and contrast my different runs. Now, on the data stage for FinTech, we have very unique types of data there. We typically have a lot of data. It's typically user data. So things like PII come into play. It's oftentimes streaming. So we have to deal with streaming data. There's a lot of things on the data stage that are very unique to FinTech. On the model stage, however, it tends to be a little more traditional. I will say, though, that we typically see slightly less like computer vision use cases, and we see a lot more NLP use cases in this typical tabular models. So that type of training will be slightly different than training a computer vision model. But the model stage is actually pretty generic to FinTech, whereas the data stage, I think, is quite unique for FinTech. Now we deal with serving. How do we service model once it's done? So on the engine side, we need to make sure that the model is scalable. So it has, if it needs GPUs, it has GPUs, it can handle the scale it needs. It stays up, and then it serves things with low latency. Then there's workflow problems. You want the ability. So in FinTech, a lot of models, like think fraud detection, they might be interactive models or a personalization model. These are models that are constantly running. They're not batch. They're like the opposite. They're interactive. At any point in time, you can hit it with a request and it will respond. That adds complexity because you can't just take it down or upgrade it very easily. On the other side, you can't A/B test in like really dumb ways, or you're just like, hey, I'm just going to run both of them and see what happens. You need to handle canary deployments. You need to be able to upgrade and downgrade. You need to be able to do A/B testing. Um, all those things fall into the workflow layer. At the same time, in fintech, there are batch use cases, which may require slightly different tools for the deployment stage. Because for batch, we don't really have to worry as much about other things, but we become more worried about batch runs, the ability to maybe run this thing in a distributed fashion. So we're not running one row of data at a time through this thing. We might be able to use something like Spark to run multiple at once. But this is the deployment stage. Finally, we hit the monitoring and evaluation stage. So this is the final stage of the MLOps layers. The engine problems to be stored here are log storage and the ability to compute to analyze those logs. So monitoring and evaluation means that now our model is in production. And every time it does something, we might want to write that into a log. We might want to just take a sample, maybe not write everything, but still we're putting what we do into a log, and we have compute over that log to be able to analyze what it's doing. Now, above that, we can build a workflow layer that adds alerting, that gives better visualization, it gives some explainability. Essentially, what it tries to do is take the compute and the log and paint a clearer picture to you on what's actually happening in production. So that's how it comes together. So you have layer 0 and 1. Layer 0 is hardware. That could just be on-prem. It could be EC2 instances. Layer 1 is compute frameworks. Those could be AWS, it could be Databricks, it could be Kubernetes. You have some sort of framework. Typically, you're not working with the hardware very directly. You're not like, again, like copying binaries to servers. You're working in some sort of framework above that. Could be Docker Compose with Docker Swarm, or it could be Kubernetes, like I said. Those are agnostic to ML to an extent. Layer 2 and 3 is where I think the core of MLOps lies. And you'll end up with different tooling for the different stages, from data, feature engineering, to model experimentation and training, to deployment, and then finally monitoring. So those 4 things are the different stages of the ML lifecycle. In each of those, there are engine problems, which is about kind of scaling compute. And then there are workflow problems, which are much more about versioning, management, just kind of the framework that you use to define and manage your different experiments, your different feature pipelines, your model deployments, and finally, evaluating your deployed models. So this is our view. And from everything we've seen, we more or less can break things down in this way. For FinTech, we find that the most crucial, painful parts are almost always the data side and the monitoring side. When you're dealing with FinTech, oftentimes you're dealing with user data. User data tends to be super messy and crazy and hard to reason about, which is why data set engineering and feature engineering becomes core. It's typically a lot of data too, and the models typically are very simple. I've found that most people use a bit more simpler models for FinTech because most of the performance gains can actually come from feature engineering, which we can control better. And then there's evaluation. Again, you're dealing with financial data. You deal with bad actors, and you need the ability to understand and see what's happening with your model so you can catch and fix bad behavior that the model is doing. Finally, I like this layer 4 of the platform layer. We have a lot of companies that use feature form, but the way feature form looks in their specific platform is always slightly different. This is where MLOps teams can take the best-in-class parts, fit them together, and build the right workflow for them. It creates a unified developer experience. This is where you can focus on those highest level metrics about this usage by making things easy to use, like having feature form and ML flow and I don't know, Bento and Aporia or some other monitoring solution. You can take those 4 things and you can give them to a data science team. And that's way better than not having those 4 things. But the platform layer is what you can use to make them fit together seamlessly, so that from their perspective, it's one coherent piece that they're interacting with. Again, at layer four, instead of four different tools that they're jumping between, around four different UIs and four different frameworks. There's a million tools in all of these categories. I'm labeling a few of them. From the top layer, there are pre-built platforms like Kubeflow, Flight, Metaflow, ZenML. And the feature store layer, workflow layer is things like FeatureForm, which can use services like Redis, Spark, Snowflake. Um, there's a variety of different tools here. And why I like this framework and why I kind of teach this framework is because for an MLOps team, the answer isn't always go and implement every single one of these things. In fact, that's almost always not the right answer, depending on scale. I think it's more important to break down your platform today into these four things. If you have models in production, you surely do some form of all of these things. Now, the way you do it might be like a bash script, but it's still done. Think breaking things down that way, and then you can find where your pain points lie. And that will show you where you should be investing in this kind of grid. Like are most of your problems data oriented? Like how we're getting features in production, we have undocumented feature pipelines, or features tend to drift and misbehave. Then I would invest on the feature layer, things like feature stores and maybe a better engine for dealing with your data. If most of your problems are in production, like, hey, we don't know what our models are doing, or they tend to misbehave and we can't catch it, or we get bug requests where someone saw the model do something strange and we can't reproduce it, so we have no idea what's happening or how to fix it, then it would be in the evaluation stage. But this is just a framework to let you think through where to make those investments. And I think kind of going back to the beginning, MLOps has to become more ROI focused, which means you need to move from thinking about just like tools to business value. For that to be true, like MLOps as a whole, like the goal of MLOps is to make ML teams more productive, which means that to get that to business value, though, the ML teams also have to be driving business value. In FinTech, that comes in the ways of fraud detection, risk management, personalization, other sorts of efficiencies that you can build of ML. FinTech is unique in that, or it's powerful in that ML is dramatically impactful to business value. Because of that, we can start to see that, okay, well, if machine learning is driving real business value, if we were to do machine learning even better, be able to iterate faster, the company as a whole would get better. And that's what justifies MLOps. On the MLOps layer, I've talked about the different metrics from uptime to usage, but all these things come together to solve real problems for your ML teams and data science teams so that they can be productive and they can drive better outcomes for the business. So that's all I have today. I went a little fast, so I ended a little early. If you have any questions, please feel free to throw them into the chat or into the Q&A function in Zoom, or as a comment in LinkedIn or Twitter, and I'll make sure to answer them. Maria will be looking at LinkedIn and Twitter to catch your questions there. I'll give it a few minutes for people to write their questions. Oh, cool. One question just came in. Someone asks, what's the best way to learn MLOps? It's a great question. There's a lot of great resources. One example is, so there's a few great resources. I kind of maybe am unique in that I learned MLOps by doing. I built our MLOps platform at my last company before MLOps was really a term. So there wasn't really much to learn about. I think there's three kind of ways to think about and learn about MLOps. One is just by doing. There's a lot of common tools that are used like feature form, MLflow, etc. Just starting to play around with those tools can actually go a really long way in helping you understand what MLOps is and why it exists that way. In terms of actual content, there's a lot of people who are great writers about MLOps that I can share after. People like Chip Hyun have written really awesome articles and even books about MLOps that you can read. And then finally, there's a lot of communities like the MLOps community, which you can join, which is a great way to meet other people who are working in industry, which is a great way to learn about MLOps. Great. Well, I'll give it one more minute, but if there's no more questions, then we can go ahead and end a bit early here today. I'll make you host again, Marie. And
Cool. Awesome. Thank you guys so much for attending our webinar. After this webinar, I will send you guys kind of a post email with links to our docs, links to our Slack community, and also the recording of this webinar. Cool.
awesome. Thanks, everyone.
Have a great rest of your